Okay, we're going to look now at integration with partial fractions. So our first one then, we're going to integrate x minus 5 over x plus 1 upon x minus 2 with respect to x. Now sometimes the first part of the question is to write this part here as partial fractions, and we'll come back at the end about how to recognize these questions. So the partial fractions is the same as just our normal partial fractions. We'll let that equal a over x plus 1 plus b over x minus 2. So x minus 5 equals a times x minus 2 plus b upon x plus 1. Let x equal minus 1. And we're going to get minus 6 equals minus 3a. So a is 2. And let x equal 2. And we will get minus 3 equals 3b. So b is minus 1. So what we're actually integrating is 2 over x plus 1 minus 1 over x minus 2, and we're integrating that with respect to x. And now these should look similar to the ones that we were doing before, that these are log ones. So this is your integration by inspection. So we'll say, well, that looks like the log of x plus 1. So if we did 1 over x plus 1, we need to get a 2 in there. So we'll have to times our guess by 2. Our guess here would be the ln of x minus 2. So if we differentiate that, we get 1 over x minus 2 times 1. So that's fine. Put our minus in the middle, and then remember our plus c. Now you can simplify these by bringing the 2 up. And then say, okay, well, we're dividing here because we'll have a minus, so we can combine the two logs and then have your plus c. Part B, then we're integrating 8x squared minus 19x plus 1 over 2x plus 1 upon x minus 2. So, partial fractions then. This is the one with the repeated factor. So we say that's a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 all squared. So our next line would be a upon x minus 2 all squared plus b upon 2x plus 1 upon x minus 2 plus c upon 2x plus 1. So let x equal minus a half, and I get 25 over 2 on the left hand side equals 25 over 4. A and the b and the c would disappear, and we get then that a is 2. Let x equal 2 then, and we'll get minus 5 on the left hand side. On the right hand side, the a and the b will disappear, and I'll have 5c. So c is minus 1. And then this is where we'll have to equate. I'm going to equate the x squares. So on the left hand side with 8, if we multiply it out, on the right hand side would have a plus 2b. We know a is 2, so put that in here and we get 6 equals 2b, so b is 3. So that means we're actually integrating 2, that was your a over 2x plus 1, plus b, which was 3 over x minus 2, and c was minus 1 over x minus 2 all squared. First two bits are straightforward enough. They look like they're going to be logs. So the log of 2x plus 1 would be our guess, and you'd get 1 over 2x plus 1 times 2. So that's exactly what we have. For the second term, your guess would be ln of x minus 2. If you differentiate that, you get 1 over x minus 2, but we want 3 times that, so we're going to put our 3 in. And then the last bit, this bit here, is not a log, okay, because we've got the squared on the bottom. So it's actually, we're integrating x minus 2 to the power of minus 2. So this is our function of a function. So our guess would be 1 more than what we have. So if I differentiated that, I would get minus 1 times x minus 2 all to the power of minus 2 times 1, which is exactly what we want. So we'll put a plus in there and then plus c. And then just tidying it up, it depends on what the question asks, how much you have to tidy this. I would always tidy the logs a bit. So we'd have ln of 2x plus 1 upon x minus 2 cubed, because we're adding, so we'll multiply those together. But we can combine the log with this fraction or the c. Part C then, 9x squared minus 3x plus 2 over 9x squared minus 4. So remembering back to your partial fractions, when the top and the bottom are the same order, so these are both x squared, this is an improper fraction, which means we'll have to divide in first. Okay, so we have 9x squared minus 3x plus 2 divided by 9x squared minus 4. So it goes in once. 1 times 9x squared is 9x squared. 1 times minus 4 is minus 4. Subtract, get minus 3x. 2 minus minus 4, so we get 2 plus 4, which is 6. So we actually have 1 plus minus 3x plus 6 over 9x squared minus 4. That's what we're integrating. So now we're going to take this fraction bit and do our partial fractions on it. So that's, we can write that as minus 3x plus 6 over, that's the difference of 2 squares, so 3x plus 2 upon 3x minus 2. So that's a over 3x plus 2 plus b over 3x minus 2. That's minus 3x plus 6 equals a upon 3x minus 2 plus b upon 3x plus 2. So I'm going to let x equal minus 2/3 first. On the left hand side I'd get 8, and on the right hand side b would disappear and I'd get minus 4a. So a is minus 2, and then let x equals 2/3. And I'd get 4 on the left hand side. This time a would disappear and I would get 4b. So b equals 1. So we're actually integrating 1 minus 2 over 3x plus 2 plus 1 over 3x minus 2. Don't forget about that 1. Sometimes people get so caught up in the partial fractions part of the question that they forget about the constant at the start and completely leave it off the integral then. So remember to put it back in again. So we're integrating this here. When we integrate 1, we get x. So don't forget about your basic integration. This is going to be a log one, so try ln of 3x plus 2. If we differentiated that, I would get 1 over 3x plus 2 times 3, but I want it to be minus 2, so I'm going to have a minus and then divide by 3 to get rid of the 3 and times by 2. and then ln of 3x minus 2. I would get 1 over 3x minus 2 if I differentiated times 3, but I only want 1 up there, so I have to have plus a third times ln of 3x minus 2, and then remember our plus c. Now tidying it up, I'm just going to bring the positive log first and write that as the log of 3x minus 2 to the power of a third minus, and then the next log, 3x plus 2 to the power of 2/3 plus c, and then combine the logs. Now there's other things you can do with this about taking out the power of a third and all the rest, but I'm not going to worry about it now. That's as much tidying up as you would really need. Okay, so recognizing the question can be an issue. Now, if it's a straightforward question where part 1 says express this as partial fractions, and then part 2 integrate, there's your big clue there. But if it just asks you to integrate, you have to spot, is it a simple log question or is it one with partial fractions? So if you look at these two integrals that we have, they look very similar. And you would sort of think, well, I'll do them the same way. But if you look carefully, if we have y, if our guess, if we use inspection here, our guess was ln of 3x squared plus 4x. When we differentiate, we'd get 1 over 3x squared plus 4x times the differential at the bottom, which is 6x plus 4. And we can say, okay, well, if we take a half of that, we would get back up to here. Okay, so we can do that. Whereas over at this side, so that first one's a simple log one. If we take the guess would be the same, ln of 3x squared plus 4x. But when we differentiate, there's nothing we can multiply this by to get 3x plus 1 on the top, okay? Because times by a half would get 3x plus 2. Times it by a quarter would get 3 over 2x plus 1. So there's nothing we can multiply here to get us back up to this one. So this is a partial fractions question. So if you if you think it's a inspection question and you try it and it turns out it won't work, there's nothing that you can multiply it by, like we could multiply by a half on the left hand side here, then it's going to be a partial fractions question, and you would rewrite our fraction up here as 3x plus 1 over x upon 3x plus 4, and then let it equal a over x plus b over 3x plus 4, and go from there. Hopefully that makes sense.